Hello and welcome to Maths with Jacob. This lesson will focus on equivalent fractions. Equivalent fractions have the same value. While they may appear to have numerators and denominators that are different, the values of equivalent fractions are exactly the same. The above pictures show clearly why equivalent fractions have the same value. In each case, half of the circle is shaded, even though the fractions have different numerators and denominators. So if we can see here, that part is shaded, which is 1 over 2, because the circle is divided into two sections, so it's 1 over 2. Here, half of the circle is shaded, but here the circle is divided into 4 sections, but 2 of those sections are shaded, so it's 2 over 4. Here we can clearly see that half of the circle is shaded. It is divided into 6 parts. 3 of them are shaded, so 3 over 6. And again, half of the circle is shaded. It's divided into 8 parts. 4 of them are shaded, so it's 4 over 8. How do we obtain equivalent fractions? If we are given an initial fraction, we obtain an equivalent fraction by doing the following. Multiply or divide the numerator and denominator of the initial fraction by the same number. Example 1. Are the following fractions equivalent? So we have a third and 2 over 6. We have to work out whether they're equivalent. The answer is yes, because the numerator and denominator are each multiplied by 2. 2 ones are 2, 2 threes are 6, so the fractions are equivalent. Example 2. Are the following fractions equivalent? 3 over 4 and 9 over 12. The answer is yes, because the numerator and denominator are each multiplied by 3. 3 threes are 9, 3 fours are 12. So the fractions are equivalent. Example 3. Find the value of the question mark so that the two fractions are equivalent. So we have 4 over 5 equals the question mark over 15. You can see here, this denominator here has been multiplied by 3 to give you 15. 3 5s are 15. So in the answer we have this. The denominator of the first fraction is multiplied by 3 to obtain the denominator of the second fraction. So, the numerator of the first fraction must be multiplied by 3 to obtain the numerator of the second fraction. Hence, the question mark is 12 because 3 4s are 12. Example 4. Find the unknown symbol in each fraction if the fractions are equivalent. We have 4 over 5 equals the triangle over 30, which equals 32 over the square. Now let's have a look. The 5, we end up with 30. 6 5s are 30, so we multiply that 5 by 6 to end up with 30. So 6 4s are 24. So the triangle's 24. Now, we have 4 here and we have 32 there. 8 4s are 32. So to obtain 32, you multiply the 4 by 8. 8 4s are 32. So 8 5s are 40. So the square is 40. Example 5. Find the unknown symbol if the fractions are equivalent. 36 over 54 equals the circle over 27. Now from here to here, you can see that 54 is being divided by 2 to give you 27. 36 divided by 2 gives you 18, so the circle is 18. Example 6. Find the unknown symbol if the fractions are equivalent. 45 over 72 equals the arrow over 24. From here to here, 72 has been divided by 3 to give you 24. So 45 divided by 3 gives you 15. So the arrow is 15. Example 7. Find the unknown symbols if all the fractions are equivalent. So let's go one at a time. From the 80 to the 20, 80 divided by 4 gives you 20. 56 divided by 4 gives you 14. So the arrow is 14. Now we'll go from here right across to here. 56 multiplied by 4 gives you 224. 80 multiplied by 4 gives you 320. So the heart is 320. And finally, from here right across to here, 80 divided by 8 gives you 10. 56 divided by 8 gives you 7. So the cross is 7. And that's a good introduction for you to equivalent fractions.